Hello. Good morning to everyone. We will continue the next session. What we are presenting today is my name is Sami Nachimuthu. I'm from Intel. I'm a senior principal engineer over there. Along with we have Mohan Kumar. He did a lot of work in this area. So what we are going to present is PUE. If you look at it, what are the issues that we have, and what are the opportunities that we can make use of it and make some modifications. Along with, I'm also going to present other work we have done in that DCEM work group. So if you look at the DCEM work group, basically you want to kind of go and look at all the metrics, all the measurements that need to be done, and however you want to create a metrics that you can disclose for a total data center life cycle. That is a major theme of Umbrella, but underneath we need to start looking at a lot more details inside that. So what we are looking at is, we are looking at all the sustainability metrics. We want to kind of go and understand what are the things there, what is related to the IT, and what is not related to the IT. Then we also need to look at is what improvements we can make. So what we have done is went through the PUE, WE, GWP, as well as CUE, kind of did a generic review of those metrics, is what is it defined today, and where we can see the gaps. That we went through the first pass. Then we chose PUE as an area that we can work on, because we can basically represent the IT systems, that we have a lot more control in OCP, that we can go and influence and make changes there. But first we have to define it. And again, when we looked at PUE, there is a IUE, that is what we are defining, infrastructure utility efficiency. As part of that, also we are looking at the network. And also we have done some work on water utilization efficiency, but we can make improvement or at least make suggestions. I will cover those 3 items. I do have a lot of slides. I'm going to skip a lot of materials here because I'm going to touch on the main points. But you can use a lot of materials are available for background reading. We will be creating a white paper and we'll be publishing it with more text content with these materials. So if you look at the PUE, it does not really define what is the sampling period for a system not aggregate, right? So you can do a monthly report or you can do a yearly report. It's not kind of well defined what the system is supposed to be doing. And also if you look at it, right, are we doing a static or dynamic? Static basically means it's calculated, dynamic means what you are really measuring out of the systems. Are you doing a full or partial, meaning are you assuming the whole system is fully loaded, or are you doing partially what you are consuming? And basically like that, we have a lot more things that it's not defined. So we want to go back and look at it, and how do we define that for IT systems, and how are you going to be able to represent that? And another thing also, like when you look at PUE, it is approaching 1. Then we really want to make sure that there is a incentive, the number you can represent in a way that people can look at it very clearly and say what can be improved there. So at a high level, if you look at it, right, PUE, the definition is total IT energy, total data center energy divided by total IT energy. So how much the data center is consuming. So if you look at it, if you have a data center cooling and data center power, that's all you're looking at the area that is IT in addition to the IT portion of it. Like I said, the average is 1.55, but if you look at a lot of data centers are trending towards 1.1 and lower. And we clearly see that it can even go further lower, right? And again, if you take that formula and take the portion of only IT and non-IT portion, you can basically say total non-IT energy by the IT energy. So here, assume the data center has a cooling and power, and those things stays constant. If you increase IT load, your number is going down rather than going up. And also, if you look at as a data center, you can think of multiple zones. But you can say zone 0 includes the zone 1, zone 2 is kind of another islands inside the bigger umbrella. And if you look at the top level power and cooling only, that's what you're going to consider under the PUE. The bottom zones, whatever is consumed, it is going on a total IT energy budget. So you are not giving incentive for optimizing it on the power and cooling side of the IT itself. And also the other thing is, now we want to combine them. How do you want to combine? Do you want to aggregate each one separately and represent it as a factor, or you want to combine it without aggregating them together or not? Right? That is another problem that we need to address. So basically, if you really look at it, right, we need to really consider IT should include the non-compute energy that is going in servers. The top one, what you are seeing is the power and cooling is outside the IT infrastructure. Bottom, we should consider power and cooling plus the red mark here, that is non-IT power within the IT itself. So then, when we start looking at the actual numbers, what is reported versus what is really going on, right? Are we measuring the metrics at each lower levels? So if you look at PUE, yes, it's measured. That's what is getting represented. And also, if you are including the non-IT energy, at a DC level, you are comprehending, you are not comprehending at a system level. What is the sampling period? It's a higher level, 12 months level, right? How many months sampling that you are taking, it's up to each person, how are they going to do the sampling. And also, what is the load currently is going on? It's maybe 40% or 50%, you can say. But that load itself is not reported outside. And also the non-electricity items, you can think of all the metrics you can collect. How you want to report is up to you. So now if you are looking at the non-IT power, what you want to include? So like I said, right, you can say like all the fans, it's not really like not producing anything for the compute side. It's helping, but it's accounted as part of the total system power, right? The fan is not a non-IT area. And also you start looking at cooling, right? If you're doing immersion or if you're doing any other cooling thing, right? It is also non-IT. All the VRs and the power bar and other things going, again, the efficiency that you're losing with IR itself, VR itself, again non-IT. So you can think of that classifications, right? And also if you are looking at the cooling, how are we comprehend the cooling, right? You could have multiple different types of cooling that you need to account for. How are we comprehending it? The cooling and how that energy spend the cooling and how are you going to recover, all those things need to be comprehended. And also if you are looking at the cooling portion of it, where the energy is going, yes, there are fans and other cooling materials are used. If you look at the power number consumed by those areas, It's up to the 10% in the traditional sense. But if I'm using a immersion cooling, you are not really like, it's not within your system, it is outside your system. So you have to consider as a, you can think of rack level consideration rather than system level consideration. So even if you put a parametrics, it will vary, but you have to comprehend at a rack level or a tank level to get the whole thing to be considered to provide the metrics there. And also if you are looking at the cooling rate, again you can say it's a rack cooled, or even if you have the rack that the cooling, you're taking the cooling from internal to the rack to the outside the rack. However, you're considering that need to be understood and addressed as part of the metrics. Again, if you are doing the immersion cooling, right? Do you want to consider that is part of the data center as IT workload? Or you want to, if you are using multiple different racks, going to consume that, however you want to account, that also you need to account for. Although we are going to utilize the water and other coolants, you need to make sure that you are accounting those parameters as part of your equation when you are building the metrics. And this is again another one, right? You could have individual power supplies within the nodes, or you can have a bus bar that's going across the nodes. Then if you are looking at just a node level, when you have individual power supplies, there is a lot more non-IT things going on. But if you are using bus bar, that is outside your node. So now you have to look at the data center level and amortize all those power that is supplied by the rack. So now, given us some of the examples of what are the things that we have to look at it and what are the issues that we need to consider. Now, if you are looking at the PUE today, you are measuring at a data center level. You are looking at the cooling and power that is going into the data center. And what you do inside the data center, the IT areas is up to you. It's very simple measurement, yes, very easy. But it does not give you all the details on optimizing the systems or compute or anything that you're doing in your data center. It's not giving incentives there. What we want to do is we want to define a matrix that allows you to understand all these different things going on and able to comprehend all those data so that you have a full reflection of what is going for your compute, IT versus non-compute areas. As we do understand, it's going to be complicated because you are going to pull a lot of data from the system to aggregate and represent a data center level view. But it has benefits, I think. We need to understand what are the benefits going to bring. We will also talk about it. Now, I think the thing is we need to kind of look at load, at what load level you want to measure. And if you are looking at the graph here, right, if you take any IT systems, there is an ideal power gets consumed because you want to get the systems up and running, but it's not doing any real work. If you are not doing any real work to produce anything that is users are consuming it, you can account that as a non-IT. And also if you are going at even when you reach the full power ratio, you may not be linear. It may be some curve-based depending on the implementations. So I think when you are considering that, you need to remove ideal power from your equation so that it's a better reflection of what is it going to be reflected in the final metrics. So this is again another way of saying putting a picture on the PUE. On the bottom side, on the left hand, you have the IT power. and the top you have non-IT. And today it's at a data center level. You have a data center cooling and power here. That's what it's used in the formula here. But actually, if you zoom in into the IT, what's happening is in the system level or rack level, you have IT cooling and IT power. Then IT hardware, which is really producing the final results. So you need to account this IT power and IT cooling as part of the new metrics. So if you are doing it a load, like I said in the previous graph, load is a better representation rather than a generic representation. So you want to look at total active power consumed and what is really going to be used for computation. And if you are looking the computational power again, you can represent another way. It's a total power consumed, remove all the power gone for thermal at a system level, and gone for a power conversion like anything IR, VR, or power supply that you use, and also remove the ideal loss. That's what real true computational power at that particular load. And if you now we want to aggregate them together, on a rack level, you can say like you can assume TDP is the maximum that you're going to get for the system. And you have removed all the ideal power and other non-IT power goes into the system. You can say like TDP multiplied by what is the current power that you're consuming for that particular load, divided by sigma of all the TDPs. That's going to give you the load for the rack. And again, you can use the same formula, aggregate them together for a data center level. And you may need to account for all the storage or other network and other things that you have, but you can use the same similar formula here. So now, if you are looking at the network switch, it's kind of similar thing. You really need to go after what is going to be produced by the network for the final consumption. So today, if you look at the network, so total energy goes to the network, data center energy goes to the network, divided by how much the network really using it. And the better formula should be, or metrics that we should go after is, how much energy is consumed for moving the bytes. If you basically look at the total switch energy divided by your payload, that gives you that byte energy. If you are able to go after the byte energy, you can understand whether the networks are really optimized or not. So because today, if you look at most of the networks, it's running at full power. Doesn't matter whether you have a ideal workload or you have a full workloads. That is, you're not giving a incentive for those people, so we should encourage that. And also another metric is how much the energy is getting reused. Because when you have the IT energy and the heat is generated, and if you are able to capture those heat and able to reuse it back, you want to give the incentive. And also, you want to make sure that if it goes to zero, that means you are capturing everything and using it back. Again, also, if you are looking at the water side, how much water is consumed? If you divide that by total energy used for the IT, you are getting a WE. Again, if you look in the details, today you are considering in the WE, you are doing only on-site water is really accounted. You should account the off-site water also. So that is a better measurement. In addition to that, you have to also look at the brown water. If you are using brown waters, if you are not considering it, you are not giving incentive for that. So you really need to account for on-site and off-site brown water that you are going to use in your the cooling other environments there. So So, as you see in the previous slides, what we are trying to show is we looked at a lot of data, and we are trying to kind of start forming some opinions to recommend those things. Even if you looked at PUE, we were kind of thinking about we need to put some weights because it's not linear, but right now we are putting a linear mechanism to represent that. So we need to do some more work to go and fine tune and get a final one. So like we are summarizing here, we are start looking at a lot of discussions. We started forming some opinions. We need to get community support and finalize that matrices. And also another thing is what we are doing is we want to write a white paper so that we can spell out all these details we are talking about it, so that you can review and give recommendations. And other thing is for us, once we kind of define this, then now, like we were talking in the previous session, we need to go to the telemetry and metrics. And like even if you look at today, fans, you don't have any easy power measurement for fan energy only. So and similarly we are. So we have to start engaging with other parties to, hey, how do we going to represent that? How are you going to consume and put in this formula that we want to defining? Also, another thing is, even though you provide all these metrics, is a data center people going to take it and publish it? And how are they going to enforce? How are we going to enforce it? Right? We need to look into that. Or we want to do sustainability certifications in the OCP so that people know these are systems are sustainability ready with all these metrics. So you still need to get a lot of high-level projects work need to be done. How are we going to take these metrics and finally productize it? Again, we like all of you to participate in the sustainability project, as well as this DCEM work group. And also we are looking for a lot more engagement so that what we are defining is going to be useful and stay for a long time. Want to open up for questions? Okay.
Hi. With respect to WE, how far down the rabbit hole do you go, given that at least 60% of our energy generated in the US today is from a thermal Rankine cycle? Every kilowatt hour of power we consume has an associated water consumption with it. So with WE, you can go far enough. You were saying add brown water and other water and things like that at the site. Do we consider the water that's associated with the energy that we consume as well in WE? And then on the PUE conversation, I know ASHRAE has done quite a little bit of work on mechanical load component and electrical loss component, and perhaps we should be looking at the server thermal energy usage effectiveness and then associating that to the overall building power usage effectiveness with respect to mechanical load components and electrical loss component.
Yeah, I think the first answer to the first one, yes, we should consider the water, however it is fully used, we need to spend more time to finalize that formula. What we are putting is what is popping up obvious, right? We have to go to the next level details. And the second one, the PUE, I'm not quite sure that mechanical, we need to understand what is that additional work is done. Because if somebody is have the data, I would like invite them to come and present it to us so that we can understand and we can fine tune our metrics there.
Yeah, hi. My name is Scott from NVIDIA. Just one quick question. You pointed out a lot of the issues with PUE as an efficiency metric going forward, especially as we shift to high-performance computing, direct-to-chip liquid, and the fans start coming out of the servers. You know, we have certain countries that are starting to regulate a PUE metric for design. Are you seeing the regulatory bodies starting to adopt something more like an IUE, as you point out?
That is Definitely true, because once we kind of able to define, we need to really go to the governments and things. Hey, we need to educate them why that is the improvement is going to benefit all of us. I agree with you. Thank you. And I will be out. If you have questions, we can sync up to.